everybody. Today we're going to see functions. The first thing that we're going to see from functions are the definition. Okay, so the way to define a new function in Python is the following. You have to write the function name, and before the function name you have to write def. Okay, this is the way of telling Python that I'm going to define a function. The name of the function is going to be this one. Okay, and then we are going to define the arguments of the function. These are between round brackets, okay, parentheses. And inside are the arguments. I will talk about arguments a little later. And after the definition and the arguments, I have to write this column over here, okay? Now, you can write a docstring to describe what the function does. This is optional, okay? It's not necessary, but sometimes it's very useful. Well, it's going to be mandatory if you're working in a company and you have to make a function, and probably you will have to document all your code. And by document your code, I mean by writing docstrings that explains what the code does. And after that, after the docstring, you have the block of statements, okay? And this block of statements, since we are writing them after this column over here, I have to write them with an indentation, okay? In this case, well, I'm always using 4 spaces indentation because it's the usual and is the most recommended. So, why to use a function? Okay, functions are very useful to avoid code repetition and also to make readable code. Sometimes it's quite cumbersome to do some things. So in order to not to disrupt the lecture, okay, like the reading of what you're doing, the reading of someone who's trying to understand what you did, it's interesting to make it inside a function so you can explain in that function what it does. And so the main objective of the code that you were writing is not very it's more easy to read. Okay. The result of this definition, okay, is a variable named function name. Okay, and this variable is going to be of type function. So if you make a new function and you type the name of the function, you're going to find that the type of this variable is function. And since it is a variable, you can use it as an argument for another function. Okay, you can use it as any other variable. You can delete it. You can use it as an argument. You can assign the value of this function to another variable name, okay, to another, yes, so you can have another name for the same function, and so on. Well, just like I told you before, the docstring is optional, okay, but it's very useful when you're collaborating with people, like in a company, okay, if you're in a company or in a firm and you're working with some colleagues about something that you're doing and you define a function. It's a good practice to document a little bit, at least, what you're doing. And also, if you don't work with other people, but you are going to read your own code in the future, which we usually do, and you don't want to find with something that is like gibberish and you don't know what it does, it's better for you, for your future you, to document a little bit what you're doing. Okay, yes, after this part over here in the block of statements, the computations of this function, okay, what this function does is in the block of statements, okay, in this block of statements, apart from many other things, you can define also new functions, so you can define nested functions, okay, functions inside other functions. We are going to see some examples to see how a new function is defined, what it does, etc. Okay, so in this case, I'm going to use the matplotlib library, okay, the pyplot module of the matplotlib library, And I'm going to define a very easy function that what it does is going to take two arguments x, y, okay, which are going to be array-like or list-like arguments, and I'm going to plot them in a pyplot function with dots, and then I'm going to write some labels in the x-axis and the y-axis, and the labels are going to be a standard, okay? It's, well, these labels is going to be x-axis for the horizontal axis and y-axis for the vertical axis. Okay, this is the function just like I defined. The docstring is going to be this one, okay? Easy standard plot of x, y with dots and default axis labels x and y. Ah, yes, I forgot to change this. I think these are the axis. Sorry. Yes, these are going to be the axis labels. So this is what we have, okay? And when we plot, well, first of all, I'm going to type help easy plot. Okay, when I write this line of code, what I obtain is the docstring of this function. Okay, so what I'm going to obtain is the header. Okay, the header of the function, and then the docstring, the small string that I've just written here. Okay, and if I write type easy plot, well, it's going to return a function. Okay, this is the type of this variable, which is the name of the variable is easyplot, and what it contains inside is a function. So now I'm going to use this function. Okay, well, instead of doing this, you know what I'm going to do is to do this thing over here, and here I'm writing x-axis and here I'm writing y-axis. Okay, so once I have this, now I can, well, now this easy plot is not the same as before, so okay, I have to, yes, and now I have this docstring, updated docstring, but now when I call the function, I'm going to obtain this y-axis and x-axis. So now what I have is when I call this function, I'm going to plot to use it with two arrays. One array for the dependent variable y and another array for the independent variable x. In order to do that, I'm going to define x like with an arrange function. Remember that arrange is going to write it's like linked space. Okay, it's going to write equally separated values. In this case, starting from 0.5 until 10 without with 10 excluded, and the steps are going to be 0.01. These are going to be the values of x, and now I'm going to compute the values of y. Okay, the values of y have a deterministic component, which is the logarithm, the natural logarithm of this x, and I'm adding this standard normal deviation with the same length of as x. Okay, so in this case, after I have defined x and y, now I'm going to call this function, and when I call this function, the result is this one. Okay, I call easyplot with x and y. Remember that these were the arguments, x and y. So I'm using I'm going to do the following. Well, this function is doing the following. First of all, it plots x and y with dots, with small dots. If we want large dots, we can use, instead of the dot here, we can use the O. Okay, but in this case, we are using small dots. And after that, it's also plotting the labels of the axis, the horizontal and the vertical axis. And that's it. That's the result. There is no nothing to return. There is no value that it has to return. It doesn't do. It doesn't give a value in the end. In this case, it only this function only does some things. Okay, and that's it. The things that it does is, well, make a new plot with dots and with these axis labels. So this is a small example of how a function works, okay? How it is defined, first of all, and then how it is called. Now, we are going to see functions that return something. Okay, so if we want the function to return a value, then we have to use the return statement. And if we use the return statement, then this is used to return one or several values, or not. Okay, if we don't use the return statement, it's going to return none. And if we return with nothing on the right side of return, then it's going to return also none. Okay, so the point is that I can use return basically to return something, and when it returns something, it exits the function. So we can use it just to get out of the function. The return statement exits the function, okay, whatever the position in the code. So I can use return just to step out of the function, and it doesn't matter if it's not the last line of the code. This is an optional statement, because if it's not present, then the function is going to run all the block of code in the block of statements, and then in the end it's going to return none after it does all the things. So it's like, in this case, for example, that I have no return statement, then it's like in the end, it's exactly the same as in the end I write return none. So in this case, this is not necessary. It's not bad, it's not, I mean, it's just the same as if I don't write anything. Maybe it is a little more explicit. Okay, if it is more explicit, sometimes it's useful, because if not, it may be, I don't know, we can think, okay, I forgot to return something, or you can think, if you're reading someone else's code, you can think of, well, maybe he's forgetting to return something, or I don't know, something like that. It doesn't matter in this case, okay, it's a very small function. If we don't write the return statement, I guess it's not so difficult to understand that we don't need to return anything here. But we could, if we wanted to, okay? We could return, for example, we could return, after we do any of these things, the while-label function. In fact, this is a function from PyPlot, and this function returns the object of the label, okay? And it's going to be a text in some specific position in the figure. Okay, so in this case, since the last, okay, so if I want to return this, it would do exactly the same, and I would return this thing that I'm telling you. Okay, so if I run this, and then I rerun this thing here, you see that now I'm returning this text that I was telling you. Okay, so this text is because I'm returning the result of this label. So when we call to while-label, this is going to make a new label in the vertical axis, but it also is going to return the text object inside the figure, which is something like this. Okay, this is a text object which is in position 0, 0.5, and it's in the y-axis. It's called y-axis. Okay, so we have this. And we are going to see some other function, okay? So in this example, we didn't have, until now, okay? In this example, we didn't have to return a function that returned anything, okay? We had this function returning nothing. And now what I have is a function that is going to return something. So, yeah, what I'm going to do is I'm going to generalize some code that I wrote before in some other chapter. So I'm going to define a function which is called filterDict, okay, and it's going to, the arguments is going to be a dictionary and a threshold, okay. In this case, I haven't written any documentation, so I have to explain. Well, you have to read what the function does. And or I have to explain it to you in this case. So we are going to make this adict. We are going to make a loop in the items of this dictionary. Remember that if I do in the items of this dictionary, what I'm going to do is to make a loop in the key in the keys and the values, okay, each of these items is going to be composed by a tuple where the first element is the key of that item and the second element is the value of that item, okay, and if the value is greater or equal than a threshold, then I'm going to use this item in my new dictionary B, okay, bdict. So this is what it does. It creates an empty dictionary here, then it loops over all the items in a dictionary, okay, in this dictionary adict. What it does, it's that if the value of this item is greater or equal the threshold that I'm giving here as an argument, then this is going to be this item is going to be appended to this dictionary, okay, to this new dictionary. And by that, remember that we have to make this assignment, okay, so we need to call this dictionary to a new key, okay, and assign a value to that new key. And after we've done all this, I am going to return this new dictionary, okay. If I don't write this last sentence, then this new dictionary that I have just created is going to go to the nothing, okay, it's going to disappear and it's not going to be returned, and we won't be able to access these variables. So the only thing that we have to do in order to use this B dictionary that I have just created is to write in the end this sentence, okay, return and then the dictionary that I have just created. So this is the way of defining the function, and now I'm going to apply this to an example that we saw before. In the example that we saw before, we had these companies, okay, and these companies, what I wanted to do is to filter this, we have these companies and this index which has several different values, okay, this might be an index that we're building for these companies, or it can be something external, I don't know. The point is that with this dictionary, I want to get only the values of the items of this dictionary where the value is greater or equal a certain value, okay, a threshold value. If we use it with a threshold of 50, then I'm going to obtain exactly the same result as I obtained in the previous example where I did something really similar to this. If you remember, what we did is basically writing this for loop, okay. So basically all I did was to wrap this code inside a function, okay, then indent these lines of code, and in the end add a new line which is the return part. And that's it. So this would be the result for a threshold of 50, and this would be the result for a threshold of 20. Okay. In this case, in the second call, we are calling this function filterdict. We are calling it with the same companies, okay, the same dictionary of companies as before, but now with a different threshold. So the result is going to be different. Okay. So now we have in the first case with 50. We had the first line, which is greater than 50, is 62. The second item, which is Microsoft with 20, an index of 20, which is not greater than 50, so it's not going to appear. Then we had MathWorks, which is 3, which is even, it is not greater or equal than 50 either. And in the end, we have Google with an index of 87, so it's going to appear in the new list. In the second example, the only company that I get rid of is MathWorks, because Amazon, Microsoft, and Google, they are both greater, the values associated to these companies are greater or equal than 20. And that is the result that we obtain. And next, in the next video, I'm going to talk about the arguments of a function, okay, and how can we define several kinds of arguments. Okay, see you.